Hi, and welcome to the Time Value of Money spreadsheet review. This is sort of a hint file to help you get started and complete the spreadsheet for time value of money that goes along with this week's chapter. Now, for the first problem here, we want to calculate the future value of $100 invested for 3 years at an annual rate of 10%. So to calculate, this is the formula for future value. See this FV equals? So here's the formula for future value. And basically what it's saying is that if you take the present value, so the lump sum is considered PV, or present value. N is years times frequency for the N, and the K is here, would be annual rate divided by frequency. So let me just go to this chart over here to describe this one time. The terms for compounding interest are annual, semi-annually, quarterly, monthly, and daily. So the frequency, sometimes denoted by the letter M, if it's an annual compounding, it would be a compounding of 1 yearly. Semi-annual would be compounding twice yearly. Quarterly would be compounding 4 times yearly. Monthly would be compounding 12 times yearly. And daily would be compounding 365 days a year, or 356 times a year. So this is the term to the frequency. Okay, so this formula, since annual is 1, we saw over here, annual is related to 1, our N is going to be 3, and our K is going to be 10% because we're multiplying, dividing by 1. So if we build a formula, and I want to show you the formula, hold on. There we go, now we have the formula bar up here. So I basically took A4, 100, which is the present value, and I multiply it by 1 plus A6, and A6 is the K in the formula, to the nth power. So use this little caret symbol here, which is right above your 6 key on your keyboard. So if you hit Shift and press 6, you'll be able to make that caret, which does the exponent, which is the exponent is F5. So if I go here, you see how the colors match: blue, green, purple. So it kind of shows you where my inputs are coming from and how they fit into the formula. So I just translated this formula into Excel to calculate the future value of $100 invested for 3 years at 10%. Now, so these other 3 problems are similar types of problems, but here's the first problem where we have a different compounding. Here we have compounded semi-annually. So in this case, the frequency is going to be, let me just adjust this, is incorrect. Okay. The frequency is going to be years time, N is going to be year times the frequency. So we know that semi is 2 from our little chart over here. So I just took 4 multiplied by 2 to get my N. And to get my K, I'm going to take 12% divided by 2 to get my K. And this would be my K. So I would use the same exact formula that I used up here, down here, to calculate my new future value using my new N and my new K. If this was quarterly, then I'd have to say this problem wasn't semi, but say it said quarterly here. Say it was quarterly. Okay, so if it was quarterly, then this would be 4 times 4, and this would be 12 divided by 4, because quarterly is 4, as denoted by our chart over here. Quarterly is 4. Okay, so you have to know the frequency in order to calculate your N and your K. You need to know what the frequency is of the problem, and once you have figured out your frequency, you can calculate your N and your K, and you can use this formula here to calculate your future value amount. Okay. Now, what if you have an annuity? So it's quite possible that you might have a different type of problem, which is FVA. So down here, we see that we have a problem FVA. So FVA has a different formula where we take the payment multiplied by 1 plus K to the N minus 1 divided by K is the formula. And so we just have to really enter the formula here. This is an annual rate, so the years are going to be N and the annual rate will be K in this problem. And we just would use this formula to calculate our future value of annuity. And what this is basically saying is that I'm going to invest $250 a year every year for 5 years at a 10% rate. So what is that going to grow to? Well, the first thing you should think about, if it's an annuity, it's 250 times 5 years. Your answer has to be larger than 1,250. Because the interest you earn every year is going to compound, so your answer should be higher than 1,250 on this. Okay, and you use this formula here to calculate that. Now, the bottom problem here is annual deposits amounting to accumulate a future sum. This title is directly from the textbook, so I wanted to keep the same title so as not to confuse you. And I'm using this payment formula. So in the payment formula, we want to calculate, we have an annuity here. So this is the future value of annuity so it's basically asking if we want to save up to $4,000 over 4 years at a rate of 8%, what should be my annual payment? If the interest rate was 0, my annual payment would be $1,000. So I'd save $1,000 for 4 years, and my future value of annuity would be $4,000. But what is my payment rate? So you could use this formula here to calculate the payment, or you can use in Excel, they do have a formula called payment. So we could look up PMT, go. So here is the payment function, and we'd say rate is 8%, periods are 4. We don't have the present value, but we do have the future value, and we don't have the type. So let me hit OK, and this will calculate the payment. So you could use an Excel payment. Now, how to get that that formula box that popped up, if you don't know, to show you how, because let me move this screen up here. And to get the formula box, you hit formulas, insert formula, and then, let me cancel that. You go to blank cell, formula, and then you could type in what you want to look for, PMT, hit go, and there's the payment. You double click on it, and you can get the dialog box to create the function. Okay. So a little Excel information. Okay. So you could use, and this is also, the textbook also nicely shows you how to use payment and various functions, and you're free. Please do that in Excel as you calculate in Excel here. Use those functions if you don't want to bother trying to create the formula. You could also create the formula. That's acceptable too. All right, so let's move on to the next page. So I want to move this back up so you have the formula here. And let me just move this up so you see the tabs. We're moving to the next tab, present value. So here are the formulas for present value. Just pull this up here. Now remember, this video is not to teach you everything about present value. It's just instructional hints on how to complete the spreadsheet. So you do need to read the textbook and watch my lecture before you work on this to really understand what's happening. But present value, we're trying to take a future amount. Someone's going to give me $100 in 3 years. At a discount rate of 10%, what's the present value of this worth today? So again, I would just convert the formula. And here, I would take my future value, multiply it by 1 divided by 1 plus my k to my n exponent, and I would get $75. So $100 if future money in 3 years at a 10% discount rate is worth $75. And that would be the same formula you would use for these cells. Now moving down, we have a semi-annual compounding problem. So this just means that when you're calculating the problem here, you have to you have to create your n and your k. So again, if it's semi, it's 2, so my n would be 4 times 2, and my k would be 12 divided by 2. So that would be my new n and k to calculate. And I'd use the same present value formula, except I just had to do a little calculation and figure out my n and k because it's compounded semi. Okay, for an annuity so the calculation of annuity payments, say you want to know what is my present value of annuity if I'm making 3 annuity payments of $1,200 for 3 years at a discount rate of 10%. So to do that, we would use this formula here, which looks a little weirdly scaled. It's similar to the other one, okay. Which is at 16. Let's keep these all the same. Okay. So the present value of annuity formula, you could use to calculate here. And it's, again, just following the formula. And on the present value page, it has its own type of payment problem. So here's the payment problem for present value. Annual payment amount to repay a loan. So again, we could use that payment formula we used from the first page, PMT. Now our inputs here, rate, we know our rate, we know our periods, we have our present value, because this is what we borrowed. We're borrowing $6,000, we're getting that today as our present value. We don't know the future value, we don't know the type, so let me hit OK, and then this would be my payment. So you could calculate this using the payment formula down here, or you could use the payment function from Excel as illustrated in the textbook and illustrated here, of course, as well. So that would be the way to solve that problem. So I'll leave it the rest of the page for you to solve. Now, annuity due is using the same formula. See this future value formula here? So we have this future value formula here. See how it's very similar? Oops, wrong page. See how it's very similar? Present value times 1 plus k to the n. And here's this present value times 1 plus k to the n. So that's our future value formula. Annuity due just adds this 1 plus k, multiply by 1 plus k. So at the end of the future value formula, we multiply 1 plus k to calculate the future value amount here. So, so basically we're taking the same formula that we calculated in our future value problem. And I bring this over to our annuity due. It's the same problem. But to actually calculate the annuity due, I'm going to have to take this and I want to multiply it by 1 plus k, which is 1.10. And this would be my annuity due. So ordinary annuity would be $133 because we're assuming the money is getting invested at the end of year 1. Annuity due assumes the money is being invested at the beginning of year 1, or what you could call year 0. And that's why we have an extra year of compounding. So we just multiply by 1 plus k. So for all these problems, you use the same formula, but you figure out, you just multiply by 1 plus k at the end. Here's a quarterly problem. So when you do a quarterly problem, your n is going to be years times 4, because compounded quarterly is 4. Remember our compounding schedule from over here? A little quarterly is 4. And then our annual rate would be our annual rate would be divided by 4 to be, so this would be our new n and our new k to calculate the future value here. So again, we'd use this same formula. Now see, this won't be correct because you can't just copy that down. So you're going to have to remake the formula. But when you make the formula, this is going to be your n, and this is going to be your k. So actually, yeah, so that's probably what the problem is in the formula. If you go down here, I put that formula in, you see that, oops, it's using cell 13. Yeah, the cells are all wrong. So you would have to adjust them and say, if I need to do my rate is actually in C12, and my frequency is actually C11. So this is just modifying a formula. And this would be 12%, or I should really say 3%, which would be C12. And then my lump sum is A10. So I'd have to, so this is a way you can edit a formula to calculate, and that's not correct. I think I have to add some more parentheses here. That's still not correct. What is going wrong here? Sorry about that. I had to adjust the, I had to have, this is 1 times 1 plus C12. I just had C12 up there. Okay, so you get the idea. You're just modifying the formula. So now this is a semi, so two quarterly problems, 2 semi problems, all using the same formula. And then we get down to, remember this side though is present value. So you would have to bring in your present value formula to work with on the other side of the annuity to do. This column would be all future value. See a future value? This column is present value. So you would take the present value formula, and again, you would multiply by, I don't want subscript, but you would multiply by 1 plus k. And I don't want this to be subscript, so I'm going to highlight this. Right click, format cells, take off superscript. Okay, so that would be your formula for the present value formula. So this formula would be for these 3 problems, and this formula would be for these 3 problems. So you have an annuity, an annual rate, a quarterly, and a semi rate here. But now we get down at the bottom, we have an annuity problem. And again, you would use the future value annuity formula and then just multiply by 1 plus k at the end. So this is pretty much a rehash of what you've done in the future value and present value tables, except now you're multiplying by the answer by 1 plus k. Okay, so let's move on. Solving for r. Okay, so if we want to solve for r here, we could use this formula here from the, that's the formula from the textbook, and we could just kind of type in the formula here to solve. So let me do that. Okay, so I took the formula, I just paused it while I did so I didn't waste your time, but I took the formula and I just put in the cells, the future value divided by the present value, and I'm bringing that to 1 divided by n minus 1. And I just keep a note on the parentheses here, because you have to have your parentheses to make sure the order of operations works correctly. You could also, as a hint, you can go to that function page again and you could look for a rate, go, and you can double click on rate, and then you could use this rate function. So it would be years, n periods would be years. There is no payment. Present value is going to be this, but for this problem I'm going to have to say multiply by -1, because really present value should be negative in solving for rate. Future value, here's our future value. Our type is 0, okay? And you'll see here that I was able to use Excel to calculate the solve for R, the rate, just as easily, actually a lot easier than when you're actually creating the formula. Interpreting the formula into Excel is a lot harder. So you're free to use the rate function as shown in the textbook, or you could interpret this formula into the cell as well. Let's move down here to solving for years for an investment. And here there's no formula, you just have to use the Excel functions. So here we're going to solve for, we're looking for years, so we're going to solve for n period. So I'm going to use the n per formula, and I have the rate, I don't have the payment, I have the present value, and I have the future value, and type, let's put 0, and we hit OK. And I calculate 11.94 years for the investment, and I can use that same formula to calculate the years to solving for the years to repay a loan. So if I'm taking a $25,000 loan for college at 11% rate of interest, and my annual payments are $4,800, how many years do I pay off my college loan? Again, I could use that n per function. So I have my rate, I have my payment, I have my present value, I don't have my future value, and I don't have my type. And it would tell me that it'll take me 8 years to pay off my student loans. So your rate of interest is probably more like 5%. So, oops, 0.05% here. So it would take, so if you had $25,000 of student loans and you're paying $4,800 off a year, then it would take 6.18 years to pay that off. Okay, so that was just an example. Okay, so you have to use that n per function for both of these, for solving both of these. Okay, let's move to mixed stream. Here is a mixed stream problem. And all the mixed stream is, annuity is a set of equal payments every year. A mixed stream is a set of cash flows that are unequal. So if we have an unequal set of cash flows, we have to use the present value of a single sum formula to calculate each one of them individually. So we'd use this formula to calculate each one of them individually. And for the present value, the n is what becomes tricky here. What is the n for each of these cases if we're trying to figure out the present value? And it's pretty simple here because n is going to equal the actual year. So if we put a formula together, for example, so if you look at this formula, B4, this is B4 divided by 1 plus B10. So B10, I put dollar signs around to make it an absolute cell, so it won't change if I copy this lower, 8%, to the exponent of A4. So A4, so this is easy. So the exponents always equal the same row. So I can actually just kind of pull this down, and I'd have my present value cash flow for each year that you have to calculate separately. And then you just find the sum, the auto sum of that grouping. Now for future value, it's going to be the future value formula, but n is going to actually be an inverse. So the n for the first year is going to be 4, 3, 2, 1, and then last year will be 0. So these will be your n's that you would use in this formula. So don't try and when you create the formula, use these as your n's for each of these future value 1, 2, 3, 4, 5, and then find the sum of it. So again, that would look like I would take the present value and I would multiply by 1 plus k, and then I would say to the n power 4. And I want to put so let's put absolutes around this, dollar signs. Now, it would be wrong if I copy this down. So this is not the right number because in future value 2, we use the exponent 3 here, and that would be the right number. So that's why I put this list down here. And because what's happening here, in year 1, I have 4 years to earn interest. In year 2, I have 3 years to earn interest. Hence the 4 exponent and the 3 exponent. So in year 5, I get this at the end of year 5. There's no time to earn any interest. So this would be $18,000. You'll see if you put the formula in with the exponent 0, that's what it would equal. Okay, so that's how you do a mixed stream. And then we have our last but not least is our effective annual rate of interest. So here we're going to calculate effective annual rate of interest. And this is the formula. Now, so we have an annual rate here. Let me go get my, actually the chart is right here. So frequency M is really frequency. Annual is 1, semi is 2, quarterly is 4, and monthly is 12. And you saw that over here. Remember our frequency chart? Okay, and R, the rate, sometimes known as K. In this case, it's R. So R and K are just the letters we would use for interest rate. So here is R, is 8%. So our nominal rate, or our annual percentage rating, is going to be 8%. So nominal is always the flat, this is the rate. But the effective annual rate, it has to take into effect the compounding. So when calculating this formula, we want to use this model for EAR. So you just have to really translate this formula into the example. So what you want to see, if it's a compounding frequency of 1, then the nominal rate and the EAR are going to be the same rate. There's not going to be a difference in the rate of that. But you should see the interest rate go up for each of these years. Okay, so you could interpret the formula and put the formula in for each of these. If you want to use an Excel function, you can use the function effect. Click on that, and your nominal rate is 8%. See, that's the nominal rate, 8%, and your periods are right here. So you could say okay, and you would get that. Let's see, you could drag this down, And yep, this is correct. And you would get your EAR for each of the years. And you see the higher the frequency of compounding, the more effective rate that you're going to earn, because now you're earning interest on your interest. And that's what makes your effective annual rate of interest higher as the compounding of frequency increases, as we learned in the chapter in my lecture. Okay, so that is calculating EAR. You can try that down here. And for the spreadsheet, when I see you submit the spreadsheet, I want to see that either you used an Excel function or you used the formula to calculate this. I don't want to see you actually just copying these numbers into the cells and typing them in, because that is not learning Excel. That is just wasting time. Okay, so here, this is my 26-minute or so help file for you to fill out and complete the spreadsheet for Chapter 5. I hope you found this helpful. And remember, this video isn't meant to show you how to do this entire file all by itself. This is a video you should watch after reading the textbook or listening to my lecture to help you complete the work and understand how to complete the Excel in this Excel spreadsheet. Okay, thank you for your time, and I hope you found this helpful.